Today we're going to start looking at a section in Chapter 8, but I just wanted to show you really quick what Chapter 8 is going to be all about. So Chapter 8 is called Polynomials and Factoring. And so there are two main learning targets that we're going to be covering in this chapter. We're going to be performing operations on polynomials as well as factoring polynomials. So let's dive into the lesson that we're supposed to look at today. We are looking at lesson 8.1, which is adding and subtracting polynomials. Our objective today, though, is to classify polynomials. So we're really going to be looking at a lot of vocabulary. Okay, that's what this section is all about. So let's dive into it. We have to know what it means to be a like term. Remember, like terms are going to be terms whose variables and their exponents are the same. So terms whose variables and their exponents are the same. So we're looking for the same letter, same exponent with that letter. Okay, so if we understand that that's what it means to be a like term, the question below says, how many terms do the following expressions have? We want to make sure we combine like terms before we identify how many terms there are. So terms get broken up by addition and subtraction signs. The fact that in part A, I see 2x plus 4. Well, 2x is going to be a term. 4 is going to be a term. They are not like terms because the 2 has an x and the 4 does not. So we call those different terms. And so because I see that there are 2 of them being broken up by that addition sign, that's why my answer is 2. Sorry, my pen is not cooperating there. All right, so there are 2 terms because they are not like terms. Okay, if I look at part B, we have 3x squared minus 3x plus 7. So I see 3x squared, I see a 3x, and I see a 7. Now notice that I see variables that are the same. I see 2 different x's. However, the exponents are different because the first x has an exponent of a 2. The second one technically has an exponent of a 1. So while their variables are the same, their exponents are different, so they are not like terms. The 7 doesn't even have an x. So because there are no like terms here, it looks like there are 3 terms. In part C, I see that I have a 2x and a 3x. Now, this time, they both have the same variable, and then technically they both have the same exponent of 1. So these are like terms. So I can't say that there are 2 terms because we want to combine any like terms before identifying how many terms we have. So when we combine like terms, I'm going to keep the variable with the exponent the same. And in this case, it's really a 2 plus 3 because I want to know if I have 2 x's and 3 x's, how many x's do I have altogether? Well, it looks like I have 5 x's. And so because that combined into a 5x, I don't have any addition or subtraction signs, and that makes it 1 term. Okay, so we always combine like terms before we identify how many terms there are. So now let's start diving into some more vocabulary. We want to know what it means to be a monomial. This is going to be an algebraic expression consisting of 1 term. Okay, so an algebraic expression consisting of 1 term. So the reason why I know it's going to be dealing with 1 is because mono means 1. So an algebraic expression consisting of 1 term. So if you look at the three examples that we have above, it looks like even though it started off as two terms with the 2x plus 3x, we combined it into 5x, that's one term, that's a monomial. So a couple other examples of monomials, it can be just a number. So like -2, that's a monomial. We could have a couple of variables as long as there are no addition or subtraction signs breaking them up. If it's all multiplication, then it's a monomial. So, xy squared, one term, no addition or subtraction signs, that's a monomial. So it could be a number, it could be some variables together, it could be a combination of all of that. So something as intense as this, 10a b to the 7th c to the 11th. Because there are no addition or subtraction signs, it's all multiplication, it is one term. All right, so that takes us to the word polynomial. A polynomial is a monomial or a sum of monomials. Okay, so that's why it was important to understand what a monomial was, because we needed to use that word in our definition for polynomial. So it can be a single term, or a polynomial could be us adding, because that's what that means when we say sum. Technically, we can add a negative, so we could really be adding or subtracting a bunch of monomials together. So essentially, everything that I had up here when we were counting the number of terms, those are all different polynomials. Let's look at a few more examples. Something like 8x to the third y. Okay, it's a single term, so it's a monomial, but that's still considered a polynomial. We could have 10x minus 2. Okay, that would be considered a polynomial. So there's two different terms here, and they happen to be subtracting, and that's okay. Or something like 5x squared minus 4x plus 7. There are three different terms there being added and subtracted, so that's a polynomial. So lots of different ways to express a polynomial. Our next vocab word is binomial. This is going to be an algebraic expression consisting of two different terms. Okay, so an algebraic expression consisting of two different terms, meaning they are not like terms. So two terms, well, that's why the beginning of it says bi. Think about like bicycle. There's two wheels there. Okay, so binomial, it's two terms, but they have to be different. So that kind of takes us back up once again to that part C where it was 2x plus 3x. Even though it looks like there's two terms, because it combined into one, that was not a binomial. Something like part A, where there were two different terms, that is a binomial. Let's look at a couple more examples. Something like x plus y. So two different variables being added together. Something like 4x minus 3. Those are not like terms. I can't combine them any further. That's a binomial. Okay, then we have trinomial. This is going to be an algebraic expression consisting of three different terms. Okay, so an algebraic expression consisting of three different terms. So thinking about the word tri, Like triangle, that's got 3 sides. So trinomial, 3 different terms. Okay, so an example would be something like x squared plus 11x minus 2. None of those have the same term. Even though there's a couple of x's, their exponents are different. So 3 different terms. This is a trinomial. All right, so if we continue looking at some vocabulary, we're also going to be asked about degrees. So let's talk about the degree of a polynomial. This is going to be the highest degree of its terms. Okay, and in order to find the degree, we're going to look at the exponents, but we're only looking at the exponents on the variables. So if we have numbers, we're not going to be looking at exponents. We're looking at the letters, the exponents of the letters. Okay, so when it says the highest, that means when you're looking at all the different terms and you're looking at all the different exponents on those variables, the biggest number exponent is going to be the degree of the polynomial. So if I look at an example, something like x to the 4th plus 2x minus 1. Okay, notice that I've got 1, 2, 3 different terms. So I want to look at the exponents on the variables. The first term is x to the 4th. So that means it has a degree 4. If I look at the second term, it has a variable. That x technically has a 1, so that's the degree of the second term. Since that number doesn't have a variable, there is no exponent for a variable, so that means that it's 0. So between those numbers 4, 1, and 0, 4 is the biggest. So that means that this is degree 4. Okay, so it's the highest degree of the terms. Okay, a second example would be something like 7x squared y minus 11x. I see 2 different terms here. In this first term, I actually see more than one variable. I see an x squared and I see a y. That y is really raised to the first power. So I want to then add the exponents of all the variables in the same term. So this is really a 3 because 2 plus 1 gets me 3. I didn't want to do anything with the 7 because that's not a variable. In the second term here, I see one variable. It has an exponent of a 1. So between the 3 and the 1, 3 is bigger. So this would be degree 3. Okay, and we actually have some vocab words for different degrees. So if I see that my final answer is degree 0 as the biggest, we call that a constant. If I have degree 1, well, we call that linear. Degree 2, we call this a quadratic. Degree 3, we call a cubic. And then it says degree greater than or equal to 4. So essentially, if I have degree 4 or anything bigger, then I'm just going to say degree 4, degree 5, and so on and so forth. So if it's 4 or bigger, then I'll just use the number. But if I see a 0, 1, 2, or 3, then we're going to name it with a vocab word. So technically, my example up here, where it was degree 3, I would really call this a cubic. All right, so we're going to give the degree and we're going to classify the polynomial. So we're going to do it by both degree and the number of terms. So in part A, I see x squared minus 6. X squared and a 6, those are 2 different terms. I cannot combine them. So as far as what my terms are, I see 2 different terms. That would be a binomial. Like a bicycle has 2 wheels, well, 2 different terms is a binomial. So now when I'm looking at the degree, I'm looking at the exponents of the variables. Well, in this one, I only see one variable. I see an x. If I look at that exponent, it's a 2. Well, right above, we said degree 2 is a quadratic. So those are my two answers. In part B, we have a negative 9x plus 2. So once again, those are not like terms. I see two different terms. So this one is also a binomial. If I look at then the exponents of the variables, I see an x, which really has an exponent of a 1, and then that number 2 doesn't have a variable. So it looks like 1 is the biggest exponent, and so we would call that linear, because degree 1 is linear. In part C, I see one number, and so because it's one number, that would make it a monomial, because one term is a monomial. So notice that in this monomial, there are no variables. And so if there are no variables, we would call this degree 0, and that has a name. That means that this is a constant. If I look at part D, we've got negative x to the third plus 2x plus 1. None of those are like terms. I see three different terms. Well, three terms we call a trinomial. When I'm looking at the degree, I'm looking at the exponents. I see an x to the third, I see an x to the first, and then the last term doesn't even have a variable. So between a 3 and a 1 for my exponents, I want 3, which is the biggest number, and that is a cubic. If I look then at part E, where I have 11a squared b to the 6th. So notice that I do not see any addition or subtraction signs, and so if that's the case, there's one term here, so this would be a monomial. And then because I see that there's an A and there's a B, so there's more than one exponent, because it's one term, I'm going to add those numbers together. So when I add 2 plus 6, I'm going to get 8. So because 8 is a bigger number than 3, because remember we have 0, 1, 2, or 3 with names, anything that's greater, we just say then this is degree 8. All right, in this last one, we've got negative 3m to the third n plus 12n to the fourth plus m squared n to the seventh. So I see 1, 2, 3, and they're different because m and n's are in a couple of them, but their exponents are different. So this means that we have 3 terms, so this is a trinomial. If I look at the first one, I see that there's a 3 and there's a 1. So I'm going to add those together. That's 4. In the second one, I see one variable that has an exponent of a 4. If I look at the exponents of the last term, I'm going to add them together. 2 plus 7 is 9. So between those three, 4, 4, and 9, 9's the biggest. So this would be degree 9. I would suggest that you pause the video and try these. So once again, 7x squared plus 14x plus 2. There are 3 terms. So this would be a trinomial. And if I'm looking at the degree, the biggest exponent is a 2, so that is a quadratic. Part B, 4x to the third. I see no addition or subtraction signs. It's one term. That's a monomial. So looking at the x, it has degree 3, and so that would be a cubic. And in the last one, I see 2 different terms. That would make it a binomial. I see that there is only one variable. Its exponent is a 1, and that makes it linear.